Okay, so in the previous video, we derived this declining balance depreciation formula that I've written on this page. Oh, fuck. 3, 2, 1. Okay, so in the last video, we went through deriving this declining balance depreciation formula that I have written here circled in blue. Now we're just going to look at applying it to a series of different questions. Now, these basic depreciation ones I have done in previous videos, so I'm going to look at some slightly trickier questions for this particular video. But they're all based around this particular equation that we talked about previously. So, in our first example, let's say that a car depreciates at a rate of 26% per annum. So every year it goes down by 26%. So after 5 years, it has a salvage value of $17,420. Okay, and we're trying to find how much the person initially paid for the car. So let's look at the important bits of information that we're given. Here, we have been given the rate of 26%. So that's this guy here in our formula. We're told that after 5 years, which is our N up here, the salvage value is 17,420. So this guy here is 17,420. We're going to want to work backwards for this question in order to find the initial amount that the car was, the initial cost of the car. So, putting in all of the important bits, substituting them into the formula, I have 17,420 equals to, I don't know what my initial price is, so I'm going to leave this as V0, times 1 minus 26%, so 1 minus 0.26 to the power of 5. Okay, so we're working backwards to find the initial cost. Remembering that here, V0 is multiplying by this thing here. So we're just trying to get V0 on its own, the initial value. So, like with any equation, we can just get this, because it's multiplying by 1 minus 0.26 to the power of 5, we can divide this through by both sides to get our V0 on its own. So, this is just a one-step equation. So our V0, we're going to get 17,420, all divided by 1 minus 0.26 to the power of 5. Okay, once I divide that through, I'm going to get to the nearest dollar, $78,504 approximately. And we can double check this answer if you want to by substituting this into this one up here and just check that it gives us the same salvage value that was stated in the question. So really we're just working through this formula, putting in all of the key bits of information and then solving for the particular unknown we're after. Okay, one more trickier question to end today. Let's say that a van was bought 4 years ago. So van bought 4 years ago for $27,500. Okay, and so using this declining balance method for depreciation, this person estimates the present value, so the salvage value, to be $8,107. Value is $8,107. We want to find what is the rate of depreciation. So we're trying to find R here. So if I write out my formula again, really we're just writing the formula and substituting in the relevant bits. We have the salvage value equals the initial value times 1 minus r to the power of n. This is what we're working through every single time. So let's center this and put in all the relevant information. Okay, so, whoa, what happened here? Apologies. We have 8,107. Okay, so we're told a van was bought 4 years ago. That's going to be our N. It was bought for 27,500. That's the initial price. And the salvage value is $8,107. That's this thing over here. Okay, so let's now write in all the relevant information. So I'm going to substitute in everything in that I've been told. 27,500 here. And I have 1 minus r to the power of 4. And now, this is kind of the trickier bit. At the end of the day, I'm trying to get to this guy over here, the rate. So I'm trying to solve this equation. I'm trying to strip everything on the right-hand side away from my r. Now, remembering here, the 27,500 is multiplying by 1 minus r to the power of 4. Now, this whole thing here, I need to get on its own because that's where my r is. So the first thing I want to do here is I notice that this is getting multiplied by 27,500. So I can divide that from both sides to strip the first layer away from my equation. So I have that 8,107 divided by 27,500 equals to this whole thing here, 1 minus r to the power of 4. Now this is where it's a little bit tricky. We notice, looking at what's happened, I've first taken the rate away from 1, and then after that, I took the whole thing to the power of 4. So taking it to the power of 4 is the last thing we did. So when we do our inverse operations, I'm going to do the opposite of that first. So this is taken to the power of 4, and the opposite to raising something to a power is taking the root of that. Now this is raised to the power of 4, so I'm going to take the square root, the fourth, we'll call it root of both sides, to get 1 minus r all on its own. So what that gives us is the fourth root of 8,107 divided by 27,500 equals 2, and now this thing cancels out taking it to the power of 4. This just gives me 1 minus r. Okay, so this looks a little bit daunting, but right now we're really at the home stretch. So I'm trying to get r on its own. So what I might do is I might add it to both sides here. So I get r plus the fourth root of 8107 over this. That equals to 1 because I've cancelled my r here. And then to make r the subject, I just want to subtract the fourth root of this whole thing. Let's just copy paste that because I can't be bothered writing that out. Copy and paste. We're going to do this to both sides, and now we can find r. r is going to be 1 minus the fourth root of 8,107 divided by 27,500. And once I do that, that gives me approximately 0.26 or 26%. So that means that the annual rate of depreciation, this thing, to get from my initial price of 27,500 to my final price of 8,107, my van had to have gone down by an annual rate of depreciation of 26%. This is probably one of the harder questions you'll encounter in this topic, but once again, the same principles apply. We write out our formula first, and then we substitute in the relevant things that we're given in the question. So I like to get into this habit of highlighting or underlining the key values, putting them in, and then we're just rearranging the equation. It becomes just solving some kind of equation, which we've done here with a lot of steps. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.